Hi, we're Team Jamming Out, one of UAH's electrical engineering senior design teams of spring of 2024. Our project aims to tackle one of the problems that many people across the world are facing right now, and that's the security threat posed by the availability of drones. Our system will be able to jam the communication of a drone and its controller, forcing emergency landing protocols to kick in or make the drone unstable and crash. But before we get into talking about the full system as a whole, I would like to walk you through it the way we went about designing it, and that's by breaking it up into three different subsystems. Those three subsystems we decided to divide our device into were the power subsystem, the UI and button subsystem, and last but not least, our antenna subsystem. We decided early on to go with this subsystem form of testing for our device because of the nature of the course and asking us to verify all the different parts and stuff. We thought this would make it easier, and in the end we believe it did, and it also made it way easier for us to fix bugs with individual peripherals on the device. So let's quickly break down these subsystems and work our way toward the completed system. First off, on our power subsystem, we have that 5 volts coming in from the USB-C and being stepped down to 3.7 volts to be stored in our battery. That then goes to a step up, which will put it to the voltage we need for our microcontroller, and in line between the battery and that step up we have our power switch for the device. It's also important to note that later on we added a battery LED indicator in line with all this too, just to make it a little easier for the consumer to use. Once this subsystem was fully set up, we tested it and our voltages were perfect, and this one was super easy, and it's the reason we tackled it first. The next subsystem we're going to take a look at here today is going to be our UI subsystem. This is the one that we were the most nervous about. None of us are software guys, so we were really concerned about this one going in, but it really wasn't that bad. It's just going to be our screen, our 2 buttons for testing functionality, and we have an LED so that when we do initiate an attack doing this, that it just blinks an LED. That way we have some way of knowing that it worked. And as you guys can see here from this little subsystem test, it worked perfectly, exactly as we wanted it to. You can scroll all through the channels. Once you click a channel, you can do an attack on it or return to the menu where you can keep scrolling through the channels. With it all finally set up, we evaluated the system for the specifications we needed, the visibility of the screen, how tactile the button presses were, and we said it was good enough for us, and we moved on to our final subsystem. Finally, our last subsystem, we have the antenna subsystem. As you guys can see down at the bottom, we have that antenna hooked up with a ton of different connections, all plugging into analog inputs, ground, or the power in. Then we have our button on there. That is for initiating the attack by pressing it, obviously. And then we also threw an LED in there as well, just so when you press that button and that LED turns on, you're sure that you're sending out an attack. And this one was a super easy test once we got a spectrum analyzer and we were able to see that we were actually producing a signal. We were ready to put all this together and see if she worked. And now that we have those 3 systems combined together, we have our full system complete. It really is just as simple as setting up these 3 different tests all on the same thing. There's no overlapping except for the power and the ground, so it really is pretty simple to bring it all together. But I do feel like I need to talk about the code just a little bit before we see the testing. The code for this actually ended up being relatively simple. It's a very simple UI with different channels that are able to be selected. You can then go into those UIs where you have attack and a return option. When you press that attack button, obviously it is going to send out the signal as well as initiate a red LED, just so you know that you're actually sending out an attack. If another group wanted to take this project even further, we have other channels and would have loved to have been able to populate them with other used frequencies, but we just didn't have time. Due to the ever-evolving nature of this project, there were a lot of changes that needed to be made on the fly. That meant during testing, we actually had it still in its breadboard phase so we could make quick changes. I only bring this up because the initial testing was going very poorly. We weren't getting any signal, anything like that. I took it over to the side, popped all the buttons out of the breadboard, all the connectors, re-put it together, and we were cooking. But to say we had it where we wanted it would be a total lie. The driver was experiencing a little bit of difficulties when we were pressing the button, but just for a moment, when it should have been about 10 seconds. So we took it back to the computer, checked it out, and realized that we had actually been doing 1 second burst instead of our expected 10-second burst. But when we were adjusting the code, we actually decided to go over a 10-second burst and just do a 30-second total blackout from one press of the button. And that actually led to the unexpected result of you can't even connect it to the controller when one of these bursts is going on. You can see here in the footage, we have Hayden trying to pair the controller to the drone while we have these longer bursts going, and we discovered that you can't even do that until the burst has concluded. So altogether, testing started off pretty bad with some bugs and connection issues with the board, but once we got them ironed out, we were very pleased with what we were able to do. One of the major downsides of the design of this project is the antenna just doesn't have that great of reach. We were super close and we were still sometimes doing attacks, and it was like the drone wasn't even registering them. So this is definitely something that would need to be fixed if this project was continued to be worked on. It would probably need a very advanced antenna so it's actually able to reach drones well up in the sky, as well as a redesign of the power system to be able to support that new antenna system.